Hi and welcome back to part 2 of exercise question discussion on galvanic cells. There are 6 questions to be discussed. Let's begin. Exercise 5. Calculate the standard cell potential for the reaction given. You are given the cell notation and the half equations with their corresponding reduction potential. In order to calculate the standard cell reaction, you have to recall the formula that E naught cell equals to E cathode minus E anode. From the cell notation, you will be able to identify that magnesium converted to magnesium 2 plus is occurring at anode and Sn4 plus converted to Sn2 plus is occurring at cathode. Now write out the half reactions for anode and cathode as shown, as well as the overall valence chemical equation. Since Sn4 plus is reduced to Sn2 plus, 0.15 is the value to enter under standard cathode potential, whereas negative 2.38 is the value to be entered under standard potential for anode. Make sure to include the signs and use a bracket to separate the negative sign and the minus sign. And there you have it, the final answer. Make sure to sustain the positive sign or a negative sign at the final answer. Without the sign, you will be penalized. Let's move on to the next question. Exercise 6. A cell is set up between chlorine electrode and hydrogen electrode. You are given the cell notation as well as the standard cell potential. First question. Draw a diagram to show the apparatus and chemicals used. Discuss the chemical reactions occurring at the electrochemical cell and calculate the standard reduction potential for chlorine gas. From the cell notation, you should be able to retrieve information like the reaction that is occurring at anode and the reaction that is occurring at cathode. Since the conversion of hydrogen gas to H plus aqueous ions require a platform to react, therefore we will be using a platinum electrode. Similarly, conversion of chlorine gas to Cl minus aqueous solution also requires a platform for reaction. Therefore, a platinum electrode is used. Now let's draw this. Here is the diagram that you are required to reproduce. At anode, the negative terminal, we have the hydrogen gas at 1 atmosphere entering in. You have the platinum electrode and the H plus aqueous solution with concentration labeled. As for cathode, the positive terminal, we have the chlorine gas at 1 atmosphere entering, reaching the platinum electrode and the solution Cl minus aqueous at 1 molar concentration. Don't forget a salt bridge is required to connect both the half reactions, and since this is a voltaic cell, a voltmeter is present, and make sure to write the E naught cell value on top since it's given in the question. The next question said, discuss the reactions occurring in the electrochemical cell. When the key term discuss is used, you are required to write the half reactions occurring at cathode and anode as well as the overall cell reaction. So at cathode, it would be chlorine gas taking in 2 electrons to be converted into 2Cl minus at aqueous state. For anode, the oxidation of hydrogen gas to 2H plus aqueous releasing 2 electron occurs. And this is the standard hydrogen electrode. Therefore, it has a standard electrode potential of 0 volts. The overall chemical equation for this electrochemical cell would be Cl2 gas plus H2 gas to produce 2H plus aqueous plus 2Cl minus aqueous. Now the third question was to calculate the standard reduction potential for chlorine. So here we will be using the E naught cell equals to E cathode minus E anode formula. The E naught cell value was given in the question. Chlorine is our cathode and the anode was our standard hydrogen electrode. Therefore, it has a value of 0. E naught cathode would be positive 1.36 volts. Make sure to include the positive sign. Conclude your answer by writing the standard reduction potential for chlorine gas to chloride ion would be positive 1.36 volts. Now let's move on to the next question. Exercise 7. Calculate the standard cell potential E0 cell for the following electrochemical cell. You are given the cell notation as well as the half reactions along with their standard reduction potential. In order to calculate E0 cell, we will be using the formula E0 cell equals to E cathode minus E anode. From the cell notation, you are able to identify that cobalt converted into cobalt 2 plus is our anode and Ag plus converted into Ag would be our cathode. Plug in the corresponding values into your equation. Make sure to include a bracket sign to differentiate minus and the negative. Your final answer should include the positive sign as well as the unit. Now let's go on to the next question. Predict whether the reaction is spontaneous or not. This can be done by calculating the E0 cell, which is E cathode minus E anode. What is given in the question is the overall chemical equation together with the reduction potentials. Firstly, separate the chemical equation into the reduction and the oxidation half. Reduction process occurs at cathode, whereas oxidation process occurs at anode. Now, match the half equations to their reduction potentials. That would be Pb2 plus converted into Pb is occurring at cathode and Cl minus converted into chlorine gas is occurring at anode. Enter the correct values. Use a bracket to distinguish between the negative and the minus sign. The final answer should include the sign and the unit. Since a negative value is obtained, therefore conclude by saying this is a non-spontaneous reaction because E0 cell value is a negative. Now let's move on to the next question. Similar to exercise 8, exercise 9 requires you to predict whether the following reaction occurs spontaneously. You are given the overall chemical equation as well as the reduction potential for the species involved. Firstly, identify the oxidation and the reduction occurring in this chemical equation. So silver is being oxidized to Ag plus, whereas Br2 is reduced to become Br minus. Now, write out the half equations occurring at anode and cathode corresponding to the process oxidation and reduction. In order to determine whether the reaction is spontaneous or not, you have to calculate E0 cell, which is equivalent to E cathode minus E anode. Enter in the corresponding values as given in the question. Make sure to use a bracket to differentiate the signs. The final answer should include the sign as well as the unit. Since the answer is positive, the reaction is spontaneous because E0 cell it has a positive value. Now to the final question. Exercise 10 is very much similar to the previous questions. However, it is just reworded differently. It is said that a cell consists of silver and tin in a solution of 1 molar silver ions and tin ions. Determine the spontaneity of the reaction and calculate the cell voltage. So first part of the question is asking you to determine whether the reaction is spontaneous or not. And the second part of the question is asking you to determine E0 cell. So what is given to you is the half equations at anode and cathode as well as the reduction potential. You know that in order to determine the reaction spontaneity, you have to calculate E0 cell, which is E cathode minus E anode. Enter in the corresponding values. Make sure to use a bracket to separate the signs. Your final answer should include the sign as well as the unit. Since a positive value is obtained, the reaction is spontaneous because the E naught cell value is a positive value. That's all for this video. Thank you.